Hello and welcome back to episode 3 of the Arduino Quick Setup Guide. I'm Matthew, this is Aaron, and we're here at the Visual World Investigate Lab at the North Carolina Museum of Natural Sciences in downtown Raleigh. Here to teach you about how to do electronics and computer programming using one of our favorite devices, the Arduino Uno, a cheap little circuit board that you can use to make pretty much anything that you can think of. In episode 1, we taught you what this is and how to put a little bit of code on it to make an LED light blink on and off. In episode 2, we used a light, but we also added a button as an input so you could learn how to communicate with the Arduino. In episode 3, we're now going to talk about how to make the Arduino move using motors and servos. Aaron?
Yeah, so let's start with a little motor talk. And let's talk about different motors you can use with your Arduino, or some of the common ones. So I have a couple here in the zoomed in screen. You'll see this yellow motor here is one of the most common geared motors, and you might have one of these in your kit. And how these work, they have 2 different input pins, and depending on how you run the electricity through that, the motor will run in one direction or the other. Have no way to control how fast other than how much electricity you're giving it, but it goes one way, and there's lots of gears in there that'll give it a different gear ratio, make it spin faster, have more torque, different things like that depending on the motors you get. And on the other side here is just a tiny version of that, and this little motor here has an end that'll spin around and around and vibrate. You'll find these a lot in cell phones. There's probably a tiny one of these in any cell phone you pick up that causes it to shake. So with these motors here, I said that it can only run in one direction, and depending on which way you run the electricity, it will run in that direction, which isn't super handy if you want to make like a little robot car. If you want to make it go forward and backwards, you'll need something else. So on this robot here, we have a little H-bridge chip, and that allows up to 2 motors to go forwards or backwards, or in one direction or the other, and also control the speed of them. So those chips are very nice. There might actually be one in the kit that you got. They also make little attachments for the Arduino, little motor shields that will have one of those built in for you. So those are basic geared motors. We're not going to use one of those today, but what we will be using are servos. So we have a couple different servos here. Show one a little closer for you. That one. Let's see if we can get this one in frame 2 with you. Nope. Okay. I'm going to show you this one right here. And how the servos work is that they will rotate up to 180 degrees in each direction. So they'll start out at like 0 degrees, and then it'll go up to 180 in one way or 180 in the other way. So it actually will not continuously spin around and around if you want it to with regular servos. They do make 360 degree servos, like the one you actually see right here. And you can't tell there's any difference on the outside, but on the inside it'll let it continue to spin around and around and around. So it works kind of like a geared motor, except it's a servo. And you may be saying, what's the difference in the servo if I can go 180 degrees one way and 180 the other way? Well, you can choose what degree you want it to go to. So you can tell it to go from 0 to 90 degrees. Or you can tell it to go to 45 degrees. And that can be very important when you're trying to have something that goes to a certain direction, a certain degree. So maybe you're making a compass or having something that points in a certain direction and follows something. You could use a servo for that. So that is the basics of servos and motors, and now we're going to show you how one of these servos works with our example today. So take it away, Matthew.
All right, so we're going to use the very typical type of servo that comes in kits. The one that Aaron was just showing you, 180 degree servo. We're going to show you how to hook it up, show you that it's very simple, and how to tell it what degree to turn to. So let's start by wiring it up. So let's get your Arduino right there. Okay, and then you need a breadboard. And then you need your servo. And that's pretty much it. Now it's possible that the ends of your servo you may not be able to plug them directly into your breadboard because maybe they're like female ends there, like Aaron's. Put over that. Yeah, see that? So in a case like that, which is how they usually are, all you have to do is trim some pieces of wire and then push them into the ends and then push the wire into the breadboard. I've used a soldering iron to hastily solder what are called little headers, which are these metal little pins, which will allow it to go into the breadboard very easily. So all I have to do is push the 3 wires into the breadboard. And notice I've done it in such a way that each wire is going into a different row. Like I'm not doing it this way. If I did it that way, then they're all actually connected to the same row, and it's not gonna work. You need them all in different rows. Right.
Yeah,
and so
remember how they go.
Right. So
rows.
Inside, I'm doing this. I'm hooking it up like that. So each one is connected to a different row. Thank you. Now you may be wondering why there are 3 wires here. The red wire is the power wire. The brown wire is the ground wire. Like oftentimes it's black, but sometimes, like in the case of servos, it can be brown. And then the yellow or orangish wire here, that's the signal wire. So that's the wire that's going to hook up to the Arduino that you're going to use to communicate with the servo, to tell it what direction to go to. So now all you need is 3 wires to connect up to the Arduino, from the breadboard to the Arduino. So, I mean, technically, depending upon if your wires were long enough, you could have skipped the breadboard entirely. So I'm going to connect up the red wire first. I'm going to connect the red wire to the row with the red servo wire, and I'm going to connect that up to 3.3 volts. This may be a 5-volt servo, however, I am powering this Arduino via the computer, so it would actually end up using all the 5 volts that the Arduino needs. It would make the Arduino freak out a little bit. Typically, when you're working with motors and servos, you're going to give them a separate power source. You're going to have them connected to a separate battery that the Arduino is not running off of. Because if the Arduino isn't getting enough voltage, it's gonna act a little bit crazy, and you don't want that. But it'll work okay. For our purposes, it'll work okay at 3.3 volts. I know that with this servo because I tested it already. All right, so now I'm going to hook it up to ground. So I've got the brown. I've connected a black wire to the brown, and that's going to ground. And then the signal wire, I've got an orange signal wire. I'm going to orange wire. I'm going to connect up to the same row as the signal wire on the breadboard, and I'm going to connect that up to, I'm going to put it on pin 9. Okay, now pin 9 is actually a special pin. There are some pins you may have noticed on the Arduino. Let me zoom in a little bit here. Some of the pins on the Arduino, some of the digital pins here, have what are called tildes next to them. If you didn't know, that's the name for the pin for that little squiggly line. You might not be able to tell, but on your keyboard there's actually a little tilde sign as well. It's next to the number 1. It looks like a little squiggle, little worm, next to some of the numbers on here. Those are very special pins. Those pins use something called PWM, pulse width modulation. And that's kind of like, so it's sending, those pins can send pulses of electricity to the part. That's how you can think of it, at least. And that can be used by a device. It can interpret that to mean different things. Like you could use it to control the brightness of an LED, sure, but you could also use it, you could also have a device that's able to take those pulses and do something specific based on whether there's like really quick pulses or really slow pulses, etc. So it just gives you some more things that you can do. These servos, you need to be able to communicate with them to tell them what direction and what degree to turn to. In order to do that, we're going to use the PWM pins to send specific pulses in a specific way. All right, so it's all hooked up. So that's good. So now we just have to go to the code. So let's move on to that. All right, so your Arduino program. Again, if you haven't done this before, episode 1 is where we cover the Arduino IDE. That's this program here that you upload code to the Arduino with. It's when you start it up, it has all this like starter code here that doesn't really do anything. We're going to go ahead and just delete it. Okay, and get started with writing the code. There actually isn't going to be that much to it, but we are going to start with something new. We're going to add a library. So libraries are incredibly helpful. All computer languages have these. A library could be pages of code or just a few sentences of code, a few lines of code that has been written by someone else to make your job a lot easier. So if we weren't using a library, we would need to write an awful lot of code to get this servo to work. But someone else has written a library that makes it very easy to get the servo to work because the library has custom functions written into it that we can then call upon. So there are different ways to get a library. Some libraries you might have to go online and download. Other libraries are built into the program or are searchable within the program. So let's go ahead and find our servo library. It's one that's built in because it's very common. So what you do is you go to Sketch and go down here to Include Library. And then in this list, Manage Libraries is where you can manage your libraries and easily download ones that are in our Arduino Foundations list. But we don't need that because this is a very common one that's going to already be in your list here. You probably won't have to go down quite as far, but you'll find it. It's in alphabetical order. Click it, and then it'll do that. It'll add a little line that's telling the program to refer to this file. This is an actual file on your machine somewhere. And so we can leave it and move on to the next thing. All right, so the first thing we're going to do after that, actually I'll back up, is call upon our servo, create like an instance for it, give it a name. So there's a built-in servo function that's built into that library. It's just called servo with a capital S. After that, you're supposed to type in what you want to call the servo. So I'm just going to call it my servo with a semicolon. You could call it potato, whatever you want. You just have to be consistent.
Potato?
No, you can't do that. I won't allow it. Now, the first function now is the setup function. So let's go void setup like we've done before. Parentheses, open curly bracket, enter. And now we need to tell it where we've attached that servo to the board, what pin it's attached to. So we start by typing the name of the servo that we created, my servo, dot, put a period there, attach. What's it attached to? It's going to expect the pin number. 9 is what we used. So that's the parameter it's going to expect in the parentheses. You'll see, as you notice, it detected attach. It recognized that and changed its color. And that's it for the setup. So I'm going to go down here below that curly bracket. So I've got the setup code inside the open and closed curly brackets. And I'm going to start on a new line here and do the loop. Now, all we're going to be doing is doing a bit of repetitive code to get the servo moving in different directions so that you kind of get the idea. Because there really isn't that much to it. Void loop. Again, a loop is a chunk of code that's read and executed by the Arduino from top to bottom, and then it starts back at the top again. So it doesn't just do what you want it to do just one time. All right. And in order to get all that we have to do to get the servo to go to a particular degree we want it to go to is type out the name of the servo, my servo, and then dot, write, parentheses, 0, close parentheses. That 0 is just the degree. That's just where we want it to turn to. That's one of the positions. So one of the positions is 0, and then if we go all the way over, it'll go over to 180. So I'm just picking a random one here. So I'll have it start at 0, and then instead of immediately going to the next one, let's put a little delay in there like we've done before. I'm going to put a delay of 1,000, which is 1,000 milliseconds, which is 1 second. And then let's get it to move again to a different position After that 1 second delay, I'm going to go to 90. That's fine. So halfway, and then delay. I'll have it delay more this time, just so we can see that there's a difference, and easier to see there's a difference in the movements. And then I'm going to do another position here. I'll do 180. Okay. And then another delay. Now, if I wanted to go in a different direction, I would just make these numbers negative. All right. Now, I've already got a curly bracket down here because it entered it, and I've been typing in between it, so it's good. And that's it for this sketch. Let's see if it works. So plug in your Arduino if you haven't already. Mine is plugged in. I'm going to go over here to the upload button. And it's the first time I'm doing it for this sketch, so it's asking me to save it. I'll just click save. That's fine. And then let me bring the servo up here on the view for you. Now it is compiling the sketch. You can see here. It's compiling the sketch. First it's error checking it again, and if it finds an error, it'll give me some orange text down here to tell me what the problem is and try to give me some hints about where it is. And then it compiles it, turning it into ones and zeros and the combinations that the Arduino is going to recognize, and then it'll upload it to the Arduino. So just waiting for that last upload step here. One thing you'll notice when you're uploading code is that when you're uploading brand new code, it always takes longer, but then when you're making like small updates to it, it's often, the updates are fast. There it is. So we can see it working there. So it's turning where it's supposed to turn, and it's pausing the way it's supposed to pause. So you can imagine all the different things you could do with this. You could put a little flag on there. You could incorporate it onto a simple like little cardboard robot. It could have little arms that move that way, or a head that turns in different directions. You could incorporate the button code that we had before so that you could tell it when to move, and maybe you could get really fancy with it and tell it how much to move. When you get more used to this code. But there's just so many possibilities with this. In the next episode, we're going to go a good bit further with this and add with some new parts, some sensors, I believe is what we're moving on to next. Now that we've gotten the Arduino to react to things like button presses, and we've gotten it to move around, now we're going to get it to detect other things beyond just touch, beyond just button presses, because there's a whole world of sensors, and those can really make your project extremely interactive and fun. So thank you for joining us today. We hope you enjoyed this and that you look forward to episode 4 of the Arduino Quick Setup Guide, filmed here at the Visual World Investigate Lab at the beautiful North Carolina Museum of Natural Sciences. Thank you very much. We'll see you next time.